Hello everybody, welcome to the third video of AlgebraCloud, and in this video we're going to deal with multiplication properties of exponents. And this pretty much just builds off what the first two videos were made of. And if you remember what a exponent was, or a base was, the base was primarily whatever gets raised to an exponent. And there's various ways you can write a base, and usually the base is found within the parentheses that is raised to an exponent. So it's either looks like this, or it could just simply look like this. Either one of them two are acceptable. So in this part of mathematics, then you will have to deal with two primary rules, and one of them will be the product of powers, and the other one will be the power of a power. So product of powers is primarily when you have two terms, so am and an, and they share the common base, but they have different exponents and they're being multiplied. And whenever that happens, then it's equal to the base that they both share with the m and n added up together. So am plus n. So that's pretty much it. Now, as for power of power, remember I was telling you whenever you find a base, the base can be found within the parentheses. Then it's whatever term is in here, which we have am, and that would be considered the base that would be raised to the power of n. And it's pretty much the same thing as saying a to the power of mn. So you can try and think of it as when you distribute n to whatever's inside, to whatever variables or coefficients are inside the base here. And we'll have a couple examples of when we do that. Okay, so I guess I'll just start with these examples. So in case 1 for product of powers, we have m5 times m7. So if you notice here, they have a common base, so it will be m. So the exponents here will be 5 and 7. So we can just write as 5 plus 7 equals m12. It's that simple. There's nothing pretty much hard about it. What will probably be hard is whenever there's more added terms and different letters involved. But we'll get to that. Remember, we're asked in case 1 to simplify, and for the second problem in case 1 we have 4 terms. We have 1, 2, 3, 4 x's as bases, and it still applies the same rule even though it's only 2 of them up here. We have x, and we're going to add all these exponents because they share this common base. So 1 plus 2 plus 5 minus 2. Now the minus 2, you should know already that whenever you add a negative number, then it's the same thing as subtracting that number. So right here we have 1 plus 2 plus 5 minus 2. So right here we have, it gets reduced down to 6, x to the 6th. So try and be careful whenever you see that, see multiple terms, and always look for the bases that have the same letter or number. And whenever they're different letters, then they usually don't mix together, like we have here. So we have, for case 2, we have y squared times a to the third times y to the negative 2 times a to the 4th. You notice here that we have both a and y as our bases, but they don't really mix together. You only deal with the bases that look the same. So let's just work with y's. We have y2 minus 2 times, and our other bases here that we're dealing with are a's. So it will be a3 plus 4. And our final answer here would be y to the 0 times a to the 7, which is also equal to a to the 7, since we know that y to the 0 is always 1, and 1 times whatever is always whatever. And so I just put it right here, times 7, and then 1 times a7 equals a7. And let's just go to our second problem in case 2. In case 2, we have 3 terms. I mean, well, we have 4 terms, but we have 3 different bases. So we have m, x, y, and then another m. Now, try to remember that always try and eliminate a to the 0, and always try to form the bases together. Try and put the bases that have the terms that have the same bases. Always try and put them together. So we have m squared and m to the 3. So we can deal with those first. So m2 plus 3 times what's left over, x to the 1 times y to the negative 3, which is equal to m over 5 times x1. Now remember from section I believe it was section, oh okay, it was the first video. Whenever we deal with negative exponents, we don't want negative exponents whenever we're trying to simplify. And always try to remember what the question is asking for. In case 1 I was asking for simplify, and right here we also asked for simplify. So another way to get rid of a negative exponent is to move it down to the denominator. So we have m to the 5 times x1. Move y to the negative 3 down to the denominator. Then we have y to positive 3. And also remember to change the sign. And that's pretty much it for the product of powers. The last problem may look a little bit difficult, and I'll just walk you through it. So we have right here. Let's see. Actually, let's start over with power of a power. So power of power, like I was saying, a base raised to an exponent, and that exponent becomes distributed amongst the base. And right here in case 1, we have s to the power of 4 to the power of 7. This is not a 5. Then we just distribute it here. So it would be s 4 times 7, which equals 28. And that's it. And it will be the same cases for whenever you see an x and negative. So we have 3 negative 5 times 2, which will equal 3 to the negative 10. And remember, we don't like negative exponents as a simplified form. Then we just gotta go over 1 over 3 to the 10 power. And that's it. Now, for case 2, you notice how we have 2 different terms inside our base. We have x squared and v to the 3. Then all that within the base raised to the power of 2. It doesn't matter. It doesn't stop that we're going to distribute. We're going to have to distribute to both of these terms. So we have 2 times 2 and 2 times 3. So x equals 2 times 2 times v 3 times 2, which would equal x to the 4th times v to the 6th. And that's our simplified form. Now, what might throw you off in the second problem in case 2 is that whenever we're asked to simplify, is that it's still, this 4 distributes out to everything that's inside the base, whether it be just the term and also the coefficient. So always remember that. Now you see this negative up front, we're not dealing with it, and just don't think about it, just think about whatever's inside the parentheses is what matters to the exponent. So right here we have 3 to the power of 4 times w negative 2 to the power of 4 negative. And then right here we have negative 3 to the power of 4 times w negative 8. Now we don't like negative exponents, so what are we going to do? Move it down to the denominator. And what's going to be left over on top? Okay, so that's it. 1 over 3 to the 10th power. Negative 3 to the 4th power over w to the 8th. Now, we're looking here, and that's pretty much what we're going to be looking for. Let's see what else. Okay. Okay, let's just continue on. Then actually, you can just expand this furthermore into this whole entire numerator. Then you see this 4 as the exponent. It applies to the 3 as the base. And from what we were saying up here is that x to the n is also a base. But if it were to have a negative number in front of it, then it would not affect the base at all, because it wouldn't be inside the parentheses on this side. So let's just do 3 to the 4th power, which is what? Which is 3, what's that? 9 times 3, 27, 3, 1, 2, 6, which is 91. So we have negative 91 over w to the 8th. Okay? So hopefully that was fairly simple for everybody to follow. And let's just get down to our case 3s. Now case 3s involve all these rules, and let's just start over on our left. So for case 3 we have negative m5 times mq to the negative 3 to the raised to the power of 4. So just remember that just try and distribute. Do one part at a time. Whatever you feel comfortable with. Just try and check your answers and make sure you distribute right. And check your exponent computation. So you have m5 times 4. Q negative 3 times 4. Okay, so that's inside the parentheses. So then we have m20 times q negative 2. Now we can further simplify this into m20 q. Move this, we don't like negative exponents, so move it down to our denominator, q to the 12, and remember the negative that's in front of the parentheses, and that will be our simplified form. Now for case 2 we have 2/5 to the power of 0 times x squared m to the power of 3 raised to the power of negative 7. Now always remember we have a 0 exponent. Pretty much just cross it out, because what it's going to turn into 1, and 1 whatever we're multiplying is always going to be whatever. So we're just gonna have to just cancel it out already. Or for those who want to see what it is 1 times x squared m to the 3 to the negative 7, which is still x squared m3 to the negative 7. Now let's just try and distribute. So you have x squared times negative 7 times m3 times negative 7. And our final answer for this would be x minus 14 times m minus 21. Now both of our numbers came out to be negative, and they're both located in the numerator. So what are we going to do?